to solve simultaneous equation. And here we have one quadratic and one linear. Then solution from what we have here. Here, the first question is given as y equals to x squared minus 4x minus 10. That's the first equation, equation 1. And the second equation, y equals to x plus 4. That's equation 2. Now here, we can substitute equation 2 in equation 1. That is, since this is y, so replace y here as x plus 2. Then which implies that what we have becomes x plus 4 here will be equals to x squared minus 4x minus 10 from here. That is, we try to bring everything to one side and rearrange. Then it implies here we have taking everything to the right hand side. Already here we have x squared, then minus 4x. Taking plus x here become minus x. Then we have minus 10 here already. Taking plus 4 here become minus 4. Then 0 will be left here. Same thing as putting it here as equals to 0 on this side. Then what we have here becomes x squared minus 5x here. Then minus 14 here equals to 0 from here. Then here we can factorize this. From here, x squared times minus 14, that's minus 14x squared. Then break this into two factors such that the factors will sum up to minus 5. So here this will be minus 7x, then plus 2x. The product here give us minus 14x squared, and the sum give us minus 5x. Then we can replace minus 5x now with these two numbers, and we have x squared minus 7x plus 2x, then plus minus 14, then equals to 0 from here. That is, we can group this together to 2 here, and factor what is common. X is common here, then we have x minus 7 here left, then here we have plus 2 common, so we have x minus 7 also left here, which is equals to 0 on this side. And here, x minus 7 is common. We factor that out. Then, plus, that means here we have x, then plus 2 left equals to 0. So is it that we have x minus 7 equals to 0 here, or we have x plus 2 equals to 0 from here. On this side, we have x equals to 7, and here we have x equals to minus 2. So here we have two values of x in this problem. Then to find the values of y, also here we can use equation 2. So from equation 2, which is y equals to x plus 4. Then when x equals to 7 here, for the first value of x, when x equals to 7, then it implies that y will then be equals to 7 plus 4. That is y equals to 13. Y equals to 11 here. That is here, the first set of solution x1, y1 will now be equals to 7, 11. So that's the first set of solution there. Then also here, when x equals to minus 2, then from this same equation 2, y will then be equals to minus 2 plus 4. That is, y equals to minus 2 plus 4 give us 2. So y equals to 2 here, and x equals to minus 2. which implies the second set of solution x2, y2 will then be equals to minus 2, 2. Now we can run the check to confirm if this will satisfy the given problem. From the first set of solution, we can use equation 2 here. Substitute 7 as x and y as 11. So here, that means 11 is equals to 7 plus 4. Of course, 7 plus 4 here, that's 11, which is equals to 11 on this side. And same thing here, when we use the second set of solutions, that is x is minus 2 and y is 2. That means y is 2. That means 2 equals to minus 2 plus 4 is equal. Then here, minus 2 plus 4 is also 2, which is equals to 2 on this side. So that's the solution to the first question here. Then also the second question here, which is number 2. From here as well, we have y equals to x squared plus 5x plus 1. We can call this equation 1. And we have y equals to 3x plus 25. Can call this equation 2. Equation 1 here is quadratic, while equation 2 here is linear. And here we can just substitute equation 2 in equation 1 directly. That is, we can equate the 2. That is, here this becomes x squared plus 5x plus 1 will then be equals to 3x plus 25. Now bring everything to one side here, which implies here we have x squared plus 5x, then 3x come here become minus 3x, then we have plus 1 here before, then minus 25. When 25 comes here, become minus, now equals to 0 here. Then here we have x squared plus 5x minus 3x, that's 2x. Then 1 minus 25 minus 24, then equals to 0 from here. Also, we have a quadratic equation here. That is, when we solve this, this becomes x squared plus 6x minus 4x, then minus 24 equals to 0 from here. 6x minus 4x will give us plus 2, and 6x times minus 4x will give us minus 24x squared. Then what is common between these two here? We have x, then into bracket, x plus 6 left here. Then here minus 4 is common here. Then also we have x plus 6 left here equals to 0 from here. That is, x plus 6 is common now, which implies x plus 6 into bracket, then open bracket, x minus 4 left, then equals to 0 from here. So is either we have x plus 6 equals to 0, or we have x minus 4 equals to 0. That is, here x equals to minus 6, and here we have x equals to 4. So we have these two values of x from here, and we can call this x1 and we call this x2. Now to get the corresponding values of y from equation 2 here, which is y equals to 3x plus 25. Then when we have, for x1 now, when x equals to minus 6, then y1 now becomes 3 times minus 6, then plus 25. That is, here y1 becomes 3 times minus 6, that's minus 18, plus 25 here. And here we have y1 equals to 7 from here. So the first set of solution x1, y1 will then be equals to minus 6, 7. Then also here, to get y2, when x is equals to 4. That is y2 now, using this same equation 2 here, then that becomes 3 times 4, then plus 25. That is, we have y2 now equals to 3 times 4, that's 12 plus 25, which gives us y2 equals to 37 from there. So the second set of solution, x2 comma y2 here, is now same thing as 4 comma 37. Now we can also check when we put in equation 2 or equation 1, and we discover this also satisfying the given problem. Then let's solve the third question from here. From what we have in question 3, from here we have x squared minus 4y squared equals to 9. We can call this equation 1. And then here we have x plus 2y equals to 1. Call this equation 2. Now here from equation 2, we can make x the subject of the formula. That is, taking 2y to the right hand side become minus. So this becomes x equals to 1 minus 2y. And we call this equation 3. Now substitute equation 3 now. Substitute equation 3 in equation 1. That this equation 1 here becomes x squared, which is now 1 minus 2y all squared, then minus 4y squared equals to 9 on this side. Then here, expansion from here, it will follow from where we have a minus b all squared, which is same thing as a squared plus b squared minus 2ab. That is here, what we have here, same thing as 1 squared plus 2y all squared, then minus 2 times 1 times 2y, then minus 4y squared here, which is equals to 9 on this side. That is, here 1 square is still 1, then plus square here affect 2 and y, and 2 square is 4, that's 4y squared here, then minus 2 times 1 times 2y, that's minus 4y. That is, here now we have minus 4y squared here, which is equals to 9 from here. And on the left hand side here, which is on the left hand side here, 4y squared minus 4y squared is cancelled each other. Then here we are left with 1 minus 4y, which is equals to 9 on the right hand side. Then we can take 1 to this side and minus 4y is left here. Then we have 9 minus 1 here. When 1 comes here, it becomes minus. That is minus 4y now equals to 9 minus 1, that's 8. So here divide both sides by minus 4 to get y. Here minus 4 cancel out, and we have y equals to 8 over minus 4, that's minus 2. So we have y equals to minus 2, which implies we have just one values of y. Then to get x here from equation 3, which is x equals to 1 minus 2y. So here x will now be equals to 1 minus 2 times minus 2. That is x equals to 1 minus times minus here, that's plus 4. Then x equals to 5. So therefore x equals to 5, then y equals to minus 2. So we can check from equation 2 here, when x equals to 5, this becomes 5 plus 2 times minus 2, and is equals to 1 from here. And this is 5. This becomes minus 4 is equals to 1. 5 minus 4 is 1, which is equals to 1. Then we have solved these 3 problems in this particular class. Thank you for joining us at Master T Math class, and also subscribe in order not to miss out on our videos. And thank you for your support. See you in next class, and bye for now.